Hello everyone and welcome to this session titled InterSystems Cloud Manager, Fast and Efficient Cloud Provisioning. My name is Steve Pisani and I'm a solution architect with InterSystems working in Australia. And today I would like to talk to you about how code is used to create infrastructure, entire infrastructures. What are the use cases for this? What is the value of using the InterSystems tools? And follow that by a demonstration of those tools. What you should expect to gain by the end of this session is an understanding of what infrastructure as code is and a better understanding of the ICM tool and how you would adopt this tool. So let's get started. So firstly, cloud computing, as we know, has for some time been a popular option for organizations and enterprises seeking to operate with agility and manage their IT costs. The ability to pay for IT infrastructure as and when you need it, and to avoid capital expense just to test out an idea, for example, is a very practical and very attractive proposition. Equally as exciting is the ability to automatically register for, set up, provision cloud services, and also automatically be able to unprovision those services when you are done using them. Whether using a public, private, or a hybrid cloud, they typically provide services in three categories, the three main types. And these are software as a service, where applications are served and are accessible by clients via either a web browser or some lightweight application. Google apps like Gmail and Google Drive or Google Play are perfect examples of SaaS solutions. Platform as a service, or PaaS, and then are an entire environment of application development, tooling, and testing. So think of it as a closed environment laboratory serving up to application developers for them to get their work done with all the tools they need. Infrastructure as service, or IaaS, is another form of cloud computing that provides a virtualized computing resources over the internet. According to IDC, 89% of companies have adopted SaaS, software as a service, with other categories offered by cloud vendors on the increase. Infrastructure as a service, on the other hand, where customers provision custom-sized storage, virtualized technology, servers, network services, is in fact the fastest growing spending area, with 5-year compound annual growth rate of 33.7%. So infrastructure as a service is certainly appealing and it's certainly growing. So even back when AWS has launched its Elastic Compute Cloud in 2006, it became evident that some tooling was needed that allowed users to design their solution architecture using some set of configuration files or a common programming language to interpret those files, and then use that process to automatically provision all the necessary infrastructure they needed. The configuration files and scripts became part of the overall solution and could be checked in and checked out of source control and managed that way, just like any other piece of software. Infrastructure provisioning as code delivers three main benefits to those who adopt it. And that's reduction in cost through needing fewer human resources to do this work, a speed of execution because it was all automated, and the removal of risk and removal of human error in the process. Now, there are several popular IAC tools on the market today, such as Terraform, Ansible, and Puppet, and each of them have their own scripting methods and processes. The InterSystems IAC tool, however, ICM, improves on these technologies by having a native understanding of how IRIS and InterSystems products should be deployed. For example, ICM creates separate volumes for binaries and journal folders and user databases as is best practice. And if deploying a synchronous mirror, you don't just get two independent servers, because ICM will invoke the IRIS APIs to configure that mirroring for you. ICM will also honor merged CPF files for finer grained control of IRIS configuration settings. And you can install IRIS as a container or containerless using regular distribution kits. Essentially, you can think of ICM as infrastructure as code tooling for InterSystems products. So how far can you go? What can you deploy? Well, you can do quite a lot. You can provision multiple data nodes mirrors, as we said, and arbiters, compute nodes for distributed caching and large-scale infrastructures, and you can do this in multiple regions and availability zones, as you might expect. You can also provision load balancers and bastion hosts of virtual machines, and not just InterSystems products. Now, ICM, the good thing about that too is that it remains in sync and grows with InterSystems products as the InterSystems stack evolves. Recent versions of ICM include support for provisioning IAM, InterSystems API management tool, as well as SAM, the system alerting and monitoring solution. Although ICM might not be your corporate cloud provisioning and management tool right now, you may have already settled on Ansible or Terraform or some other product. ICM can still be leveraged for many use cases. For example, to automate the setup of an architecture for running your test suites against an IRIS database, or to test different combinations of an IRIS architecture as a proof of concept. Another use case would be to use ICM in someone's continuous delivery pipeline to automate environment setup or to automate the deployment. So there's various use cases for using ICM today. ICM is distributed as a Docker image available from the InterSystems public Docker registry or the support site. And I will demonstrate how to set up your security files and walk you through the credentials and the JSON configurations needed in order to use ICM. Once you have completed the definition of your architecture, you've designed it and you've specified the configuration files, you start deploying all the required nodes by simply using the ICM provision command. And then shortly thereafter, you'll use the ICM run command in order to populate those instances with an instance of IRIS in order to set them up and to configure them correctly. And we will show all of this in the demo, which we'll get to very shortly. Once your architecture has been deployed and it's running in the cloud, beyond setup, ICM can also be used to manage your infrastructure in ways outside of just deployment. For example, to be able to push code to your instances, to be able to upgrade your instances of IRIS, or to start and stop IRIS, but also, once you're done, to unprovision, destroy, and clean up your entire footprint in the cloud. So with that, let's just do that. Let's get to the demo. I will be using AWS in this particular case. Today, I will be deploying a multi-node architecture, not just a single server. And I'll be doing it only in one region. I want to have a load balancer. I want to have a distributed set of 3 compute nodes. And underneath that, we'll also have a database server. I'll actually have 2 database servers, which will be configured as mirrors, as synchronous mirrors. I'll be having an arbiter, which will govern that synchronous mirror. And I will also be deploying an instance of SAM. So here we are ready for the demo. I've started up a Linux shell. ICM is provided as a Docker image. We will need to pull down the Docker image first, and then we will need to start a container with that image. Here I am doing this using the docker run command, which will pull down the image by default. Given that I have already pulled the image, this will be a very fast process. It will just, as soon as I hit enter, start the container and place me into the shell ready to start configuring it. So here I am in the ICM container. The first thing you would need to do when you start this from scratch would be to generate the files which are required to secure communication between ICM and the cloud provider. We provide 2 scripts, keygen.ssh. This sets up the keys required for secure communication, and TLS.sh, which also sets up SSL and TLS files for the same purpose. You really only have to do this once, and you can hold on to this container and you continue provisioning from this container, but there is now security files set up for that purpose. With the image we provide, there are some samples to get you started. You'll see in the samples folder There are subfolders for every cloud provider we support, or even vSphere, because we support deploying to that too. In those folders are layouts, sample configuration files. The first one I'd like to draw your attention to would be the credentials file. The credentials file should contain the authentication keys that the cloud provider requires you to provide in order to use their APIs, in order to gain access to their server. Then there are the other two most important files: the defaults.json and the definitions.json file. So the samples I won't spend too much time on these files right now, because I will want to put in my settings, and also I will be modifying the other sample I have here, the definitions of JSON, and then I can explain exactly what they contain, and we'll be able to start provisioning my architecture. So let me make those edits now, and I'll do them. I'll make those edits whilst the video is not running. Okay, so I've made the changes. I've configured my configuration files. Let's have a look what I've done. Quickly, we will have a look at defaults file first. So you'll see I've made my changes here. I've added my label. This label will go on to the instances which I provision. I have also decided to provision container instances of IRIS. So I have told the configuration to go and pull this instance and deploy that on my cloud servers. This could be your own container with your own application. It doesn't have to be obviously IRIS. But I'm also providing a username and a password for the registry where these images reside. I haven't put the password in because this is confidential. I will be placing that in before I kick off the provisioning. Other changes, I've made sure that my license directory is properly specified and it has an IRIS key in it. I've changed the region where I will be deploying this, because I want to deploy within the Asia Pacific Southeast region. I've changed the zone. I've nominated my instance type of my machine. I've modified my credentials. I certainly did that, otherwise nothing will work, and a couple of other settings. Okay, so those are the default settings which will be applied to the architecture that I'm going to deploy. Some of those settings can be overridden by the more specific configuration file. The second one that needs our attention before we do anything else. So from here you can clearly see I am creating two data nodes. I am putting them in a mirror set. Okay, they are in a mirror set because I have mirroring set to true in the previous file. I'm creating 3 compute nodes, and I'm putting a load balancer in front of them just by adding this line of this element in this section here. I have a section where I've decided to include an arbiter. This arbiter will be configured from my mirror, my database mirrors. And I've also decided to include SAM, the System Alerting and Monitoring tool, the new tool from InterSystems. All of these are going to deploy for me very, very quickly, and they're all going to be configured. So I double checked that I have everything in place, and all I need to do now to start the provisioning of my servers is invoke the ICM provision command. ICM is now contacting my defined cloud server, cloud provider, which is in this case AWS, preparing a plan for what needs to be done, issuing those commands, and essentially utilizing AWS's APIs to configure my several nodes, my network, my storage devices, everything I need as described in my definitions and defaults JSON files. I will let this run. I will speed up the video and I will then resume once it's all finished and all configured. There will be another phase which we need to do after that. So let's just wait for this to finish what it's doing. So as you can see, ICM has finished provisioning or finished instructing AWS to provision our architecture. It's given me the list of nodes and the IP addresses that I will then use, but not yet. There is one other thing left to do, and that is to push to execute on these servers, and that's to issue the ICM. I'll clear the screen first, and that's to issue the ICM run command. Now the ICM run command will use the state of the architectures that we've just finished setting up and download IRIS from whether from a Docker registry if I'm deploying container-based instances of IRIS, or if I was deploying containerless, it will install IRIS on those servers. There is one prompt it's going to ask me, which is just here because I chose to leave this particular password outside of my file. I could have placed this into my defaults file. This is the system account passwords that we normally need to specify with all installations of IRIS. It's prompting me on the screen for that, so that's fine. And away it goes. You can see clearly again here, ICM works in a multi-threaded manner. It is doing things in parallel, which increases the performance and reduces the time it takes to get the system up and running. So as soon as this finishes, we will have a look at we will log into IRIS and we will also log into SAM to just see that everything is up and running and the whole environment, the whole topology, including IRIS, has been successfully deployed. So I see that ICM has now finished its run phase. It's basically installed IRIS, I beg your pardon, on all the nodes it needed to. It's configured them. I've had no errors whatsoever, nice and clean. The only thing left for me to do would be to log on to those servers and make sure that they are up and running, and it will be a good validation point right now. I'm given the URL to the management portal of the primary data node. I'll just copy that here and I'll fire up my browser and see if I can gain access to it. In fact, it is up and running and I should be able to log in, and there you are. This is the my cloud instance, my data node, my primary data server. Let's have a look at what we have. We have a mirror set up. Clearly here, both nodes are set up in a mirror set. That's already been configured for me. I've not had to do anything other than specify I wanted a mirror in my definitions file. I can also perhaps see whether this server has any ECP clients connecting to it, any compute nodes which are part of the whole architecture. And I can see, as I asked for three, there are three compute nodes connecting to this database server. Again, all done, all ready for me to now to make use of this architecture. Okay, so all that is left to be done is to check that my system alerting and monitoring instance is configured and that it's correctly running. So I'll just copy the URL, provide it to me, I'll head to the browser, and let's log in, and there it is. I can see it is up and running. but has it configured all my instances. I do in fact see that there is my Pisani cluster, and I have my data nodes. Everything's up, data node 1, data node 2. I can dive into this. You can please recommend that you visit other sessions in this conference to learn more about our monitoring tool. But you can see ICM has gone ahead, understood my topography and created my cluster and already added everything to it. Well, thank you for watching all of that demonstration. It would really encourage you to visit the learning.intersystems.com website, where you will find more information about ICM and also about other InterSystems products. Throughout the sessions today and throughout this conference, you will learn more about other parts, and you will learn more, if you like, about SAM and other features that we have. I hope this has been extremely informative. I hope you have had a good you have continued to have a great conference, and I'd like to thank you for your attention today.